Kubernetes security learning series point of view. 19th topic is sign and validate images. So I'm in a training.linux foundation here, and under the supply chain security, sign and validate as a part of the previous session, right? So sign and validate images. So let's try to understand. So basically here signing and validating of images. Image could be anything, right? So here basically when we look at the Kubernetes pods, right? Pod will have a images. So if you look at here, always we will specify a image name with colon and version name, right? And if you look at the another way of mentioning is nothing but it's a image with it's a digest. So let's try to, this is a digest. So here nginx 1.14.2, here this is a eco server at SHA-256 some big number. So basically let's try to understand what is the benefit of using this one or using this one, and which is the better for Kubernetes security point of view. So here tag versus digest. So basically if you look at the tags, right? So tags are basically sequence of tagging to an image, but whereas a digest is basically useful when you wanted to deterministic, you will be determining the deployment and repeatable deployments. So basically we will use a deterministic, especially this is a keyword, we will use a digest. So tags basically, let's say I will go to the Docker Hub, right? Docker Hub, right? And Docker Hub here, let's say, sorry, it's a busy box or nginx or whatever, you search anything, right? And I'll go to the images, right? Here say 1.34.1. so basically here under the description there is a 1.34.1. so here tags 1.34. Right, 1.34.1 you search, right? Basically here, right? So basically this 1.34, 1.-ubic glibc, these are the tags. But whereas if you open this one, right, I opened one and say anything, right? Here the digest is here, right? Digest is basically typically 256 and it's a very big hash code, right? So let's try to understand that. Tags can be updated pointer to digest. So basically here when you talk about the any image, it will have a various tags, right? So every tagging is pointing to one of the digest. This digest is a unique for each tagging. Now digest is a what exactly? This is a cryptographic hash which will indicates about the image. This busybox 1.34 has this particular digest which indicates basically a unique identification of cryptographic hashing of this particular image and tag. Now is it typically 256? Basically why this is tagging? Basically tag is an immutable, means once the tag is assigned nobody will be able to edit. If it is edited means definitely this digest will is going to change. If somebody say created a some malfunction or maybe virus, it contain a virus busybox 1.34.1 and you are using, then that digest will be different. That's what it means. So what we will do is in this particular session we will try to compare this particular digest how you will use, so that you are using a legitimate image. If you look at the structure of an image, basically every Docker image will have an image index and as well as a image manifest. So what exactly this image index will have? Image index is talking about the what its operating system and what are the available operating systems of and that image, which digest and which tag. Let's go to the Docker. This is a busy box. If you look at the OS architecture, these are the various operating system it's available, like AMD 64, ARM based, right? Ikkada PPC. So there are various hardware specific compatible, and it has a unique digest at the this particular sequence level. So that's what it's a image index in high level. But whereas what is image manifest? If you take any version, say here Linux, say if I go here, I just clicked on this one, I just clicked on here, I'll close the old one, right? So it's taken a specific version, that version specific, basically the manifest means what? Basically manifest will have a configuration object of this particular specific OS architecture you have choose that. And also we know the Docker image will have a layers, right? So layer 1, layer 2, something like this. So Docker image is a completely in the form of a layers. Each layer has its own digest, but ultimately every image wise there will be a digest at the root level as well. But if you wanted to know the details of this particular every specific version, then you will be able to see the image manifest, right? Now basically this example I have taken from this Google Cloud. It's a very good and maybe you can go and read, right? Now image index, basically what is image index? Image index is nothing but it's a high level manifest about the platform details. Yes, this is image index and it's a platform details, what platforms and all, right? That's what right. And if you look at the image index, I have taken example from the GitHub repository, it's official, right? If you go to the Google OCI image index, enough OCI image index, it will take you to the GitHub, right? This is the what is image index and all, and it will tell you, and also it has a one example as well. That's the same example I am using here. Basically here if you look at here image index, it has a manifest, media type, size, digest, platform, and this is a platform for PPC 64, this platform for AMD 64. So only two. So image index is a JSON format, and as well as it has a various media type, size, platform and all, what kind of a media it has internally as per the OCI specs. It's a two examples are given, but if you look at this particular image, it has a very big JSON, but for the idea point of view. Next is image manifest. What is this image manifest? Image manifest is also similar to the index, it's a JSON format, but it will have a layers. So in the previous slide it has a manifest with the operating system, then whereas here it's a layer. So layers, first layer, second layer, third layer, and what this layer contains, every layer has a own digest, because Docker builds a layer by layer, right? Now it's JSON document, yes, it's a JSON format. Second is it has a system layers and metadata, yes, it's a system layers and it has all the metadata, media type and all, overall what is the size and all, every layer size and every layer digest, etc., so that it's uniquely identifies. Then what exactly it provides a manifest? It's provide a configuration and set of layer information. If you wanted to dig more about the Docker image, what kind of a layers and all, then you can check the manifest and you can generate as well. And one more thing is for a specific operating system, yes, you will choose the index, then after that index specific a manifest you will pull. That's what. And how to see the Docker manifest? Say if you look at the I'm in a Docker, I'm using a Docker for desktop, right? Clear, say Docker images, I don't have any Docker images, so what I will do is Docker manifest. So a Docker manifest inspect hello world. So basically I wanted to see the hello world image specific manifest. So it will simply go and pull the hello world image and its manifest. So let's wait for a few seconds. If you look at here, it's generated the manifest for the hello world image. So here see manifest of hello world manifest. What is a manifest? This is the operating system, this is operating system, and after that scroll down. So this is the one. And if I look at the manifest in full detail, hyphen verbose, then it will give the more verbose details. So again I will pause the video. Yeah, so here I have specified, scroll up, right? Docker manifest as a hyphen verbose. So in the previous it has a very high level detail, but whereas if I specify verbose, it given me the lot of information about the each and every operating system architecture. What is a version of a manifest? It's a version 2 currently, and its media type and all, every layer information, it has a full complete details about that particular image. So that much of information is enough to know, right? Now today's topic is basically our is signing of images. So if you look at here, right, sign and validate images. So first we need to sign the image. How to sign means, if you look at the Docker right here, this busybox 1.34.1 is signed by somebody. Who is signed? Whoever is the uploader, right? That's what the signing. So basically, what is a signing? Signing is basically indicates a digital signature. How you will do? By using a Docker content trust. What this Docker content trust basically allow the publisher. Say for example, I am a publisher of a one particular image. Say, let's say, right, here, hello world JS, this is a my Docker image I am going to build. I am a publisher of this hello world JS. So being a publisher, I have to upload with the digital signature, so that people will identify that this particular image is by the this guy GVR, it's me. Yeah, publisher has to sign on the every tag push. Yes. So if you go to the busybox, right, and busybox tags, right, you take a busybox ubic c, right. So here this one, so every tag will have a digest, but it's not a compulsory, but better to, as a better practice, you need to add a signature, right. Signature is why it's to identify, right. So what exactly it will give the benefit? It will give you the integrity of the publisher, so that you will know, yes, this particular image is by the Mr. this particular person, so that you will confidently use in your Kubernetes cluster. And how you will use Docker trust? There is a Docker trust command. By using that you can. So Docker trust is enough, and content trust. So if you look at here, not this one, so Docker trust here. So this is a Docker trust command. So how we will see that, right? So this is a diagram. Basically I am a registry. In the registry I want to upload these two versions, and if you want, if you have an organization and every version, and you can add a signature from a various other signers. In my company there are three different departments. First version is signed by one department, second version is by both the department, third version is by three different departments. Yes, that's possible. So basically the sign is basically indicates that this is a verified publisher. Next is a Docker trust. So in order to sign, you will be using a Docker trust. What it will do? Basically, first initially you will be building a one Docker image and you will tag it. Then after that you have to upload this into the repository. Say, let's say for example, this is my Docker hub, this is my username, right? And if you go to the repository, I have only one repository, hello world -python, which is uploaded 1 year back. Say, let's say I wanted to build a Docker image hello world node, right? And I wanted to upload basically with the version 1 hello world node -1. Then first thing is I need to generate a public key by using this command. Then second is allow the public key, whatever you generate, you know how you are signing with the whatever the repository as a trusted signer. This guy is a trusted signer. Then after that you are adding, then after that sign it to the version 1. So this public key will be at the repository level, but for this version you are signing. Then after that, once you sign, just you can inspect. So once you sign that, then automatically that image will be available here with the specific digest. So that's how it will work, right? So now next is, if you wanted to pull the only Docker images, those are the trusted, or those content is basically signed. Maybe you need to set this environment variable and then Docker pull, then automatically it will pull the only signed versions only. That's what. Then second is validation Docker pull. So basically if you go to the Docker hub and busybox, say I wanted to pull 1.34.1, right? Say these are the commands in my presentation, right? You can pull the Docker pull by using its version and 256 and it's a, so what I will do is here, right, docker images, right, then nothing is there. What I will do is I will try to pull this 1.34 which is the busy box. So what I will, docker pull busybox colon 1.34.1, yes, 1.34.1. then after that when I click here, right, so it will open my, right, and it's a digest, you see, digest is, this is the one. So I will copy, right, and go to console, paste. When I enter here, then it will pull the busybox 1.34 which has a digest of this one, right. Now I downloaded, right, now docker images, right, now my busybox is downloaded, right, and there is no tag. Why? Because you downloaded by using the, it's a digest. How to see the digest? Docker hyphen digests, docker image is digest hyphen digest. So which will give the what is the digest of the particular image. This is uniquely identify which is what is my production version, which is a, and you can compare this B699 something, right. So you hear B699 something, right. So now this is how you can pull, right, and how to verify. So then how to, I wanted to see this, how to see that, yes, in order to verify, docker inspect, and what is the image id, this is the image id, and when you enter here, basically you will see docker specific its complete information. What is a docker id is this one, and what is a repository digest, which is this one, right, which is same as the, this is a digest. So digest is used to identify images are uniquely and for the security aspect as well, right. Here and it has a various other container configurations, image specific digest, and it has a configuration, and this configuration has a various architecture and OS and all rest of the information, and its layer specific digest also. Next is pod level validation. So whenever you create a pod, usually you will be specifying image colon and it's a tag. But in order to achieve the security, basically in order to make sure you are using exact this one, then you will be specifying this particular digest which is available in the official documentation as a at 256 at and then 256 colon, and it's a digest id you will be using. So this is my simple pod, right, which is a busybox 1.34. so in order to use my digest, so what I will do is I will copy this particular SHA-256 colon digest. So it's a very simple, go here and just and just paste. So this is the way you can use 1.34 with the its a digest, so that you are uniquely identifying that you are using a right version from the right digest. So in order to demonstrate that, I am in a 2 node this cluster, right, the kubectl get node, right, this is really this Kubernetes cluster, right. So what I will do is I will create a one pod.yaml, right, I'll just paste it, right, simple, it's done. What I will do is I'll just save, right, now clear created. Now kubectl apply -f, and then this is the pod.yaml, right, its pod is created. Now kubectl get pod, right, it's running, it's perfect, right. So now kubectl describe pod, my pod, so basically if you look at here, image is basically I have specified with its own digest, so that my image is right images is used. Say let's try to tamper this, right, and try to make it as a my pod 2, and they'll tamper it to, instead of 8 I will make it 9, just tampering. And I will go here and then go to my cluster, right, I will create a vi pod2.yaml, right, and I will paste it here, right. So this digest is not correct, but right, I'll try to apply and see what happens. Kubectl apply -f, pod2.yaml, right? So pod is created, but let's see the status. kubectl get pod, right? Error image pull. Why error image pull? Because it's not a legitimate image digest. That's why it's throwing error. Say if I say kubectl describe pod, then my pod 2, right? Then if you look at here, this manifest for this particular not found, manifest is unknown, which is nothing but it is Kubernetes is checking the manifest with this particular digest, it's not matching. So that's how the things will work. I hope this is basically it is helpful. So whenever you wanted to achieve a security best practice, as always use the image digest in the pod level, so that you will be using a right one. I do not use the latest, always use with the it's a digest. It's a very good practice. In that way you can achieve a Kubernetes security. I hope this particular session is helpful, and let me know your feedback in the comments. Thank you.